Hi, greetings everyone. Today I would like to talk about the production of xanthan gum coating solution for a banana's shelf life extension. And in this context, we would be using Musa Paradisiaca, which is commonly known as pisang brangan. This would be the outline of my presentation, which includes introduction, problem statement and significance of study, objectives, literature review, materials and methodology, results and discussion, conclusion and recommendation, references, and last but not least, Gantt chart. For introduction, I would be starting off with Musa Paradisiaca. So Musa Paradisiaca is commonly known as pisang brangan. Over the years, it is well known with its benefits of having a lot of nutrients such as carbohydrates, fiber that makes it flavorful, and also a nutritive fruit. However, keeping Musa Paradisiaca in a fresh state in a long time is impossible since it is easily spoiled. And according to the statistic, 20 to 30% of production of Musa Paradisiaca has been lost annually due to shortage of sufficient infrastructure and also the lack of exposure to post-harvest technology. Next, moving on to edible coating. So edible coating is a thin layer of film that is used to coat fruits or vegetables directly to prevent the movement of moisture and oxygen between the surrounding and also the food coated. It can be safely consumed and digestible by human. It helps with providing barrier and also protection to the fruit. Moving on to cassava starch, it is one of the crucial components in the making of edible coating. In some countries, cassava has been identified as the major source of carbohydrate, and to produce cassava starch, the root of cassava plant will be bleached and dried. The product from both of the processes will result in cassava starch. Next, we have xanthan gum. Xanthan gum is produced by the aerobic fermentation of simple sugars with the help of bacteria called Xanthomonas campestris. The bacteria are the cause of black rot in vegetables such as broccoli and also cauliflower. Lastly, we have zinc oxide nanoparticles, which is defined as nanoparticles of zinc oxide that has the count of diameters that are less than 100 nanometers. Zinc oxide nanoparticles involves a high catalytic activity due to it having a large surface area as well as having small sizes. Zinc oxide nanoparticles vary in terms of physical and also chemical properties due to the way it's synthesized. The problem statement in this research would be Musa Paradisiaca having a short shelf life due to microbial spoilage, and the significance of study of this research would be extending the shelf life of Musa Paradisiaca and also to reduce the cost of post-harvest and the losses of post-harvest bananas. The objectives in this research is to produce edible coating using xanthan gum and also to determine the effect such as shelf life, antibacterial properties, and also physicochemical properties of xanthan gum in the production of edible coating coated on Musa Paradisiaca. Few researchers proved that edible coating that includes the use of xanthan gum helps in reducing the weight loss of food coated, and it also has the efficacy to better the quality of fresh cut fruits. Xanthan gum also helps in reducing the growth of psychotropic microorganisms as well as the formation of molds and yeasts in fruits. The properties of gums that I have attached in the table shown are the properties of xanthan gum, guar gum, Arabic gum, and also alginate gum. The methodology started off with the production of edible coating, and then to application of coating solution on Musa Paradisiaca, shelf life study, antibacterial activity of coating solution, and lastly, physicochemical analysis of Musa Paradisiaca. The results started off with the results of shelf life study of coated Musa Paradisiaca. On day 0, all of the bananas are in maturity index 1 and all of the bananas are in green color. They were firm and rigid. But as you can see on the table that I have attached, On day 9, you could actually see an obvious changes to the control banana, the encoded one. You could see that it actually changed color from green to yellow, and it turned from maturity index 1 to maturity index 5. But during day 9, the banana that was labeled as X and G, which was the one that had xanthan gum and guar gum in it, still in maturity index 2. On day 12, you could actually see some black spots and dark brown spots appeared on the peel of the one that was encoded, the banana that was encoded. For day 15 and also day 18, you could actually see that the encoded banana is unsafe to be consumed, while the others that were coded were still in good condition except for day 18. During day 18, all the bananas are unsafe to be consumed. Next, we have the results of inhibition zone of antibacterial activity of coding solution. Here I attach 3 different results of 3 different percentage of zinc oxide nanoparticles. The first one would be 0.5%, the second would be 1.0%, and the last one would be 1.5%. You could actually see an increasement in the inhibition zone based on the percentage of zinc oxide nanoparticles involved in the coding solution. Based on the graph I've attached, you could actually see the inhibition zone for E. coli was higher compared to the inhibition zone of Staphylococcus aureus. The inhibition zone increased as the percentage of zinc oxide nanoparticles increased. To start off the results of physicochemical analysis of coded Musa Paradisiaca, the first parameter was weight loss. As you can see on the graph, the coded banana has lower percentage of weight loss compared to the uncoded one. This is because in the coding solution, the starch acts as an oxygen barrier that minimizes the losses of oxygen and also they minimize the rate of respiration in the banana. Hence, the coded banana experienced lower percentage of weight loss compared to uncoded banana. For the treatable acidity, you could see that both uncoded and coded banana decreased significantly. A reduction of acidity in the fruit during ripening is accompanied by a reduction of the organic acids, which is called malic acid, into sugar. For the treatable acidity, you could see that both The next parameter would be pH value. Both coded and encoded banana held pH value that increased significantly, but the coded banana has shown lower pH value compared to uncoded one. The pH value in both coded and encoded banana increased, while their titratable acidity decreased, along with increased storage time. The decreasing of the most important organic acids present in banana fruit, including malic acid and citric acid, which act as substrates for the enzymatic reactions of respiration, is the most likely reason for titratable acidity reduction and the accompanying pH increase. Next would be the total soluble solids for both coded and uncoded banana. The total soluble solids value for uncoded and coded banana has significantly increased based on the graph I've attached, with the increase of storage period. The higher the increasement in total soluble solids in uncoded banana may be associated with the degradation of starch and also dehydration of fruit. The next graph showed the firmness value for both coded and uncoded banana. As you can see, coded banana has been more firm compared to the uncoded one during the last day of analysis. This proved that the uncoated banana has become a little bit mushy compared to the coated one. The last parameter for physicochemical analysis of coated Musa Paradisiaca would be the color. There were three categories that included in the measurement of colors, which are L value, A value, and B value. L value indicates the difference in lightness and darkness, while A value indicates red and green, and lastly, B value indicates yellow and blue color. The conclusion and recommendation in this research would be the edible coating was produced using xanthan gum. The effect as shelf life, antibacterial properties, and also physical-chemical properties of xanthan gum in the production of edible coating coated on Musa Paradisiaca was determined. The shelf life of Musa Paradisiaca was prolonged from 12 days to 15 days. The antibacterial activity was inhibited by zinc oxide nanoparticles. And in future research, it would be advisable to use different type of starch, different concentration of zinc oxide nanoparticles, and other fruits.